Welcome everyone to the 5th session of the International LoongArch Biweekly. And before we start, this meeting is organized by Longsun Hobbyist Community, a third-party organization unaffiliated with Longsun Technology or any of the companies, entities, and institutions mentioned in this document. Please limit discussion to open information only. We will not answer questions for products and designs currently under development or testing. Please refrain from making political statements or commentary for the duration of the meeting. And finally, opinions expressed in these meetings are strictly of the individual speakers. And without further ado, let's move on to upstream development, and we'll first go to Xiro Yao for GCC and bin utils.
So let's start with GCC. Two patches we've already discussed previously, one for the 64-bit memory access instruction on 32-bit target, the bug introduced by the stack protector fix. Another for optimizing the dot product with sign and zero extended vector operands are already merged. Jia Haoxu fixed the argument type for LoongArch schedule reassociation with. It's a target hook called by the target independent code, so the upstream decided to change the argument type, but they somehow left LoongArch over. So anyway, it's not fixed. Meng Qinggang proposed a fix for the DTP relative relocation in the debug info. This is something for describing the address of the thread local symbols. Previously, there is a 0x8000 offset, which seems pistol from MIPS, but on LoongArch the offset should be 0, or we can say there should be no offset at all. So the patch will remove the offset once it's merged. In bin utils, the alignment fixes we've discussed previously have been already merged. After the merge, the upstream maintainer Alan Modera noticed the LD-R fix has broken 32-bit LoongArch and fixed the issue. As we've pointed out, the distro should backport the input section alignment fix and rebuild affected packages.
Okay, and now we'll move on to Linux kernel, and let's give the floor to Wang Xuerui and Xilong.
Hello. So let's start with platform support for our Linux kernel changes in the past 2 weeks. As for the new patch sets, there's Chenhua Cai suggesting to register ISA or LPC devices before the PCI, handling the PCI root port. This is mainly for compatibility with some systems with quirky firmware. We'll have a more detailed description for dispatch sets use in the later section for distro maintainers. Oh, sorry, my cat is interfering with me. Okay. Chenhua Cai also fixed the faulty reboot flow by properly handling offline CPUs during stop this CPU helper. Previously, those CPUs are expected to announce their grace period when they're already offline. So the RCU subsystem was left with deadlock, where the expected grace period will never actually end. Changhua also has uh, submitted two build fixes. One is increasing the task struct offset for array 32-bit systems to the this is actually the highest ceiling for a single add I instruction. Because of the previous enablement of the thread info in task. This key config change has ballooned up the size of the task struct, so the offset needs to be increased as well. He has also fixed build failure where my cat has attacked me. Never mind. He has also fixed a simple issue where some 64-bit instructions like add I.d were mistakenly exposed to the 32-bit fields. The other patch sets are undergoing multiple revisions. Let's move on to the next page. Okay. In terms of the KVM subsystem, there's one new patch set. George Guo has fixed the issue where the kernel loaded by kexec may overlap the FDT loaded by QEMU trashing it. This is actually I think it should be 3 or 4 independent changes. This is quite complicated, basically making multiple pieces of information dynamic. So kudos to George Guo for fixing this quirk, for pinpointing the causes. Well, because the surface symptom is simply the kexec kernel has no boot process available. That's because the early con information and the frame buffer information was stored in the QEMU provided FDT, which is stepped on by the kexec loading process. Okay, for the BPF subsystem, we also have George Guo fix a bug regarding BPF tail call, and he and Tiezhu Yang have done some improvements and polishes around the BPF JIT and tail call spot as well. Tiezhu Yang and Yang Tiezhu and Zhao Chengguang has also bumped their other patch sets to new revisions respectively. Okay, uh, I think that's all for Linux kernel.
There's actually another page. Oh, well, there are also additional functional fixes. For instance, you have Hao and Jiang's support for enforcing write and execution and dumping support on kernel page tables. George Guo actually also fixed address space mismatch during kexec, maybe. Hou Pengpeng changed, made a minor fix to kernel configuration, changing config I2C designware slave to simply config I2C slave to reflect a change in the 7.2 cycle. Zhang Hongcheng also fixed 30-page tracking in PT and PMD handling when hardware PTW is enabled. This will mostly correspond to 3B6000 and 3C6000 systems. Bingbing Zhou fixed the handling of IO-man pointer in the video mode parsing code of the Longsun 2K0500 BMC frame buffer driver. This was a revision 2. Okay, and moving on to U-boot, this has been about 2 years since we have any news on this front. A developer, Ziyao, has introduced preliminary LoongArch support to and bumping the patch set to revision 2. The patch set was based on Yang Jiaxun's work back in 2024. And this new version has already been successfully booted on QEMU. The patch set has since received quite a lot of review comments, and there will be a revision 3 for sure. But before that happens, I think the upstream expects a full CI support for LoongArch on U-boot before a revision 3 can proceed. Okay, and now moving on to box 64, let's give the floor to Liu Yang.
Okay, thank you. Can you hear me?
Yes.
Okay, since most of the content listed here are quite minor, so I'm going to pick only the items that you might find interesting. So first, we added presets and frequently used the options to the box64 configurator. So now, for any x86 application, you can choose a preset that suits your application the most between compatibility and performance. Next, we added a compression rate to the output of the codekit file the listing command. We also added the LoongArch implementation of a few SSE instructions. So these instructions should be the last ones left unimplemented for the SSE extension until now. So next page, please. So we also improved the handling of the FPIM x87 instruction. This fix in the Death Stranding 2. So the game is working quite well right now. And next page. And so okay, the last one we added and adjusted the profiles for several games, including the Death Stranding 2 and the Doom 2016, and along with some other games. So that's all from me. Thank you.
Okay, thank you, Liu Yang. And I think interestingly, we got a few submissions from Gleb Popov or ROD for this week's Biweekly, and they have requested for me to read this out. So he's submitted a few pull requests and issues in the upstream community in the past 2 weeks. So to begin, we have Trafic, which is a modern HTTP reverse proxy and load balancer that makes deploying microservices easy. So for this, he submitted a patch to bump the rollup component to the latest version to allow building on Long64 muscle. So it's LoongArch 64 target for the muscle C library. Node.js and npm package Docker node, he has submitted a patch to fix build with a correct OpenSSL config on LoongArch 64. Dockcross, a cross-compiling toolchain in Docker images, introducing support for Linux LoongArch 64 targets. Serial, Snappy Java, Java port of Snappy, a fast C++ compressor decompressor developed by Google, adding again Linux LoongArch make target. Now that LoongArch Dockcross is available. For Alpine Linux, this is Docker Alpine, the official Docker image for Alpine Linux. He has added official Docker file for LoongArch 64, but evidently it was closed. ClickHouse, which is an open source column-oriented database management system that allows generating analytical data reports in real time, submitting both LoongArch 64 build fixes and updating include files for LoongArch 64 in the sysroot repository. And finally, there is an issue for Erlang's OTP, which is a set of Erlang libraries consisting of the Erlang runtime system, a number of easy-to-use components, mainly written in Erlang, and a set of design principles for Erlang programs. However, when building, is it building or runtime? Let's see. So yeah, so during build time, let's see here. During build time, he ran into a lock order violation during build time, and there is now an issue open. So if anyone is interested in taking a look at this issue, you're welcome to do so. And before I move on, there is a slight interruption to the other, as in previous sessions, we had a segment for a collection of, we call the other upstream projects updates. But unfortunately, there was a job change to the person who is in charge of that. So we will have a period of interruption until the next international session, and where it should be coming back. And for DPDK from Vladislav Shapov, who noted to me that he would like for me to read it because he is not too confident about his oral English. But anyway, so he has ported DPDK vectorization to LoongArch LSX, LASX, and CRC32. The vectorization part was based on the SSE and AVX sources. All tests passes successfully. You may find the work in progress tree at the link here. The branch also contains the other branch also contains the LASX vectorized Intel i40E driver. However, the testing was limited as it requires an appropriate network card. So anyone who is willing to help with testing, that would be great. And he also mentioned that he plans to upstream all the patch sets. And now moving on to distro and OS updates. First of all, for tips for maintainers, as Xenon has mentioned in the Linux kernel segment, please consider backporting the following patches for the Linux kernel if you receive reports of kernel panics or resets during boot, where Chinese commercial distros like Linux and EOS 25, if they work and not on mainline kernels, you might want to backport this patch from Chunghua Tai, which registers ISA and LPC PIO devices before the PCIe root port. So this issue is mostly commonly found in with devices with Kunlun firmware. Currently, we know of 3 or 4 boards who has this kind of issue. So if you do, here's the patch for reference. And if you have Lenovo Kaitian N60D or Inspur CP300L3 laptops, which are both based on the 3A6000 processor, if the touchpad doesn't work, please consider backporting this patch from Zhibangxie. And similarly for laptops based on Excelsior NL38N11, which is also 3A6000, this laptop is probably the most commonly found one for 3A6000. Previously, a downstream patch existed in AOSC's kernel tree, but there is now an arguably better implementation down below, which is currently listed as a request for common patch. So upstream has reviewed it, is confused about what it's doing, and is awaiting input from Longsun engineers. The reviewer has also expressed doubts on the conformance of the modern approach with interrupt resources duplicated in the CRS block. So hopefully we'll hear from Longsun engineers, and this patch will be merged in one form or another sometime soon. And for DVFS, please apply this kernel patch, currently from AOSC, but it should be upstream lately in the near future. Or advise the user to not enable DVFS in case they're using the 2026-05 firmware release. So it's reported that when DVFS was enabled, it can cause anomalies like boot failure without the kernel patch, or it can show sometimes 6 gigahertz CPU frequency on 3B6000 systems. So the release is currently listed as community preview only, but we hope to get more input, and hopefully before the next release in August, all the issues should be ironed out. And now for Longfire, Mr. Lee should be talking about this, but I'm wondering if it's here or not.
Yeah, I'm here. Can you hear me?
Yes.
Yeah, hello everyone. And so first of all, I'm a big fan of Linux since I started my career in almost 30 years. And I always wanted my own custom built Linux distribution. So Longfire it is. And so Longfire, the background, it's a port of IPFire to LoongArch 64 architecture. And the reason I want to try LoongArch is because no one tried it. So I want to try, I want to be the first one to do it for network operating system. So the difference between Longfire and IPFire is I enabled the kernel eBPF feature for networking and tracing support. I tried to convince the IPFire maintainer to enable the eBPF, but they rejected the suggestion. So I cannot upstream a Longfire project to the IPFire. And so for usage scenarios is this is a good use case for a home internet or small medium-sized businesses, I think, because you can you can add a lot of add-ons like software. You can custom build it, and yeah, for example, I built a few eBPF based applications for Longfire for network acceleration. And because my another interest is BPF, so this can be also a test bed for BPF features for LoongArch. And so far, I have found a few BPF bugs, and the Longshan BPF community developers is able to fix those bugs, and huge thanks to them. So here are the links. You can, like for people in China mainland, you can get the source code from the gt.com. And for people outside China mainland, I have the repo in the GitHub. I also have a YouTube channel. Used to be some broad technology I have used before, but now I want to focus on the Longfire. And yeah, so I try my best to sync the Longfire code base with the IPFire, and so it's almost the same when you run Longfire as IPFire, except you have the eBPF feature enabled. And yeah, so can be also generic network centric operating system. And I think it has a huge potential. Like my background is in the enterprise load balancer area, and you can run this as a load balancer or as a firewall or as a router, whatever you want. And yeah, I think it has a huge potential for business. And yeah, that's what I want to mention. Thanks.
Okay, thank you, Mr. Lee. And now we'll move on to AOSC. And in the previous 2 weeks, Linux 7.1 and 7.2 RC kernels are now available for testing. Linux 7.1 kernel includes trackpad fixes for Lenovo Kytian and Inspur laptops, as mentioned before. And you may join the test repository with the command here, and also for 7.2. The June 2026 distro update has been released, including Linux 7.0.13 with DVFS support, and also driver updates for LoongGPU and Glenfly. There are also other notable updates with also Laser 2026-624.0. This update fixed the issue where background video does not play after the FFmpeg 8 update. The Pro 5.42.2 is now available after a long hiatus in updates since 5.36. BinUtils and rebuilt libffi to fix the aforementioned alignment issue has also been made available in the stable channel. In the past 2 weeks, 21 security updates were including 4 critical and 50 high-severity vulnerabilities. So when you can, please update your system. You may also join our Telegram group with the QR code to the right for further discussion. And now for Proxmox VE, we'll move on to Wu Kaiyang.
Hello, so for Proxmox VE, we now have a new installation ISO available for download. Please, if you want to install Proxmox VE on our machine, you can download the latest one here. Also, in the past week, I've made multiple LXC templates for different distros available on LXC templates listing on PVE. So including AOSC OS, the Debian 13 based on Long 13, Alt Linux, Fedora Remix, Gentoo, Alpine, Urban Euler, and Arch Linux. So, and during my research on the LXC support status on PVE, I found several problems, and I've patched them and submitted the patches to the upstream, waiting for reviews. Also, just a notice, you can always update your PVE instance using the following command. So you can see these listed templates above in your LXC templates download section. And that's it for PVE.
Okay, thank you, Wu Kaiyang. And now for Basalt.
Hello.
Hello.
We close to official release for our main products. There is a link for alt server. You can download and try it. Still going to release alt server and network station this summer or early autumn, and we are working with multiple software vendors to encourage them to make LoongArch ports for their products. It's in progress. That's it for us for these 2 weeks.
Okay, thank you. And now for community news and events. First of all, for DebConf 26, let's move on back to Wang Xuerui. And he might not be here. So, okay. So Xenon will be traveling to Santa Fe, Argentina for DebConf in July. And please look out for LoongArch demo devices running Debian and Proxmox VE. So we have 2 devices that will be on display. First of all is a desktop computer. It's a water-cooled 3B6000 16-core system with a Longsun 3B6000 processor and AMD Radeon GPU. And there is also a NAS embedded system, the B-Link ME Pro. You might have heard of this manufacturer for small AMD desktop computers. This one in particular is powered by Longsun 2K3000 and comes with 2 3.5-inch bays. And finally, Longsun Hobbyist Community is a proud sponsor for DebConf 26. And there are also news in terms of new ways to find news and make friends. We have started a subreddit r/LoongArch this week with some slight issues, but now it's mostly smooth. You're welcome to post any of your questions, any of your experiences, even your computer builds on there. And we have also started a news channel on Telegram called Long Way Forward. and all meeting events and software update news will be made available there. And if you are, a maintainer of an upstream project that has a particular interest in LoongArch, you're welcome to ask for admin permission in that channel, and you will be welcome to post news there as well. Okay, and that should conclude all the community news for the past 2 weeks. And now we have once again a special presentation from Maria, who is quickly becoming a resident expert in UEFI firmware. So let's give the floor to Maria.
Yes, hello everyone. Please, first slide presentation. Okay, thank you. Today we will look at what happened inside your computer from the moment you press the power button until the OS takes control. I originally prepared this presentation for Russian students to help them learn more about LoongArch and Lunxen processors. So, next slide. Next slide. Okay, thanks. This topic is broad and interesting for my opinion, so it fits both experienced engineers and beginners. I will give you a general map of the firmware world without going too deep into the heavy details, just enough to get you oriented. Next slides. These terms are often mixed up. I searched a lot of forums, so I can say how in the slide. BIOS is old and obsolete, UEFI is a modern standard, and firmware is the actual software stored on your motherboard chip that implement UEFI. And when people say enter the BIOS, they are actually opening the UEFI setup menu. Next slide. The firmware lives on a small CPI flash chip on your motherboard. When you turn on the PK, the CPU copies the first instructions from that chip into its own cache because it can't access the main RAM yet. This lets the processor start running code almost instantly. Next slide. Firmware is critical because it wakes up all your hardware before the OS even loads. If it also checks the security of your bootloader, and it builds tables in memory that describe your system to the OS. And in this, at this slide, you can see 4 theses why firmware is very neat to learn. Next slide. Firmware is divided into 4 clear stages: SEC, PAY, DXE, and BDS. Each stage handles a specific job and hands off control to the next one. The first inside is the SEC phase, second is the PAY, next DXE and BDS. So your OS starts and the last phase of starting and initialized firmware. Next slide. I think that all of you know this, but I need to speak this. On standard x86 systems, the boot process is familiar and well documented. But Lunxen has its own architecture called LoongArch. And because of that, the firmware handles memory and booting in a completely different way. Next slide. I want a little speech for secure boot. Secure boot is a security feature that checks if your bootloader is properly signed with a trust digital key. If the signature doesn't match, the system simply won't boot. It's all about making sure no unauthorized code gets executed. Next, what I want to say at the next slide is a little for a CPI. Next slide. Thank you. The OS can't automatically detect your hardware. Instead, the firmware builds a CPI tables in memory that tells the OS actually how many processors, how much memory, and what devices are connected. So how can you see? MEDT tables, it's a description of processor and input controllers. CRAT, it's a NUMA topology, which memory is close to which cores. MCFG, it's a PCI configuration space map. And DCDT or CSSDT, it's a description of devices and power management methods. And if any errors in the CPI tables lead to unstable OS operating, the chaos is extremely difficult to diagnose. Next slide. Next slide. I just make two parts of the presentation for students, but part 2 is the anatomy of UEFI. Now that we have the big picture, let's open the hood and look at how the firmware is actually structured and runs. I will break down the boot phases and look at how to really it's going on. Next slide. The firmware isn't one big binary file. It has a 3-level hierarchy. Yes, hierarchy. The full flash image, logical volume inside it, and a file system inside those volumes. Each component is stored in an open place. First, I want to say is the firmware file system. Each file in that system is a container. Next slide. Yes, it can hold code, can hold text or raw data like images. For example, the manufacturer's logo is stored as a raw bitmap data that you can extract and even replace if you want to customize your firmware. Why I see Russian language? Sorry, it's my bad. Section types, P32, it's code drivers or apps. UI, it's a human readable model name. Raw or freeform BMP logos, unistrings, and DXC deeper. Depex, it's a list of protocols dependence of the dispatcher. Okay, next slide, please. There you can see 4 sectional boot phases. The boot process always goes through like same their phases: SEC, PAY, DXC, and BDS. Knowing these phases helps you quickly figure out where system got stuck during starting. At the SEC phase, you can see security runs from cache. In the PAY phase, you can see initialization of operation memory. In DXC phase, going loading and running all drivers that you have. And in BDS phase, boot device selection and bootloader launch. So next slide. And we start talk about every phase more quick. The SEC phase runs the very first code that CPU executes. At this point, there is no RAM yet, so everything runs directly from the CPU cache. If something fails here, the system stays completely silent. No beeps, no output, and no any image. Next phase, please. Next slide. The pay phase is next, and its main job is to initialize the system's main RAM. Once memory is up and running, it builds a map that tells the next stage where its memory located. And here you can see 3 types. First, it's pay modules. Pay code is organized into panes. Each pane solves one task: initializing the memory controller, chipset, or finding FIB modules containing the DXC core. Handoff blocks, it's the next. When memory is ready, Pay builds a list of hops, data structures describing the discovering physical memory and its attributes. This list is fed to the DXC core as a resources map. And the critical transition after Pay completes, the code moves from the cache into operational RAM. the DXE core is relocated there and restarted with a full stack and heap. Next slide. DXE phase. The DXE phase is where all the hardware drivers are loaded. For example, USB, PCI, network, video. This is when you typically see the manufacturer's logo appear on the screen. For example, you can see a beautiful red logo Loongsun when you start loading your processor. And here you can initialize PCI root bridge and device enumeration, USB host controllers, network adapters, video controller, logo appears on screen, how can I say before, and the CBI tables are published to memory. Next slide. Boot device selection, or BDS, the last phase. The BDS phase is the boot manager. It scans your drivers for an UEFI file named, for example, boot AA64.efi on Loongsun or boot x64.efi on x86. Once it finds it, it hands control over to the OS bootloader. So that first step, device search, second step, standard path, and third, handover. And next slide. At this slide, a little presentation for UART logs. I before and first or second Biweekly show presentation about how to read logs from UEFI. And this little picture for students. The UART log is your main debugging tool. It shows every step of the boot process in real time. If the system hangs, the last line of the log is usually a very clear clue about which phase failed. So you can see like this picture from left side that in UART you can see very clearly which phase are failed. For example, SEC, PAY, DXE, BDS, and fix any problems. And next slide. So, if you want to learn more, check out the QR codes for the official UEFI specification and the LoongArch manual. Those are great places to start your own research, and thank you for your time and the whole presentation for students. But I hope that you enjoyed this pics. Thank you.
Right. Thank you, Maria. And there are also useful resources for UEFI specifications and ISA manuals. And yeah, let's move on to question and answer. Do we have any questions from the meeting or from the live streams?
Hello. May I comment on the last slide about the statement that LoongArch is a proprietary ISA? Well, this is a nuanced situation because LoongArch kind of sits in between a truly closed proprietary ISA like x86 or ARM, but it's not quite open, literally and completely in RISC-V sense. Well, actually, LoongArch is a kind of semi-open or controlled open model where the standards are technically placed under the governing body in Chinese Automation Academy. One of its SIGs is basically for the development and promotion of LoongArch, both inside China and internationally. So you will get a LoongArch license to make your own LoongArch design or to license LoongArch IPs and to iterate and contribute to the standards. So, while you have the rights to contribute, you have to build consensus with other players like Longsun or other stakeholders. So it's kind of controlled, open, or some openness with more governance structure. Not entirely permissive like RISC-V, but not completely closed like x86, ARM PowerPC, or the other traditionally closed variants either. So this is a very nuanced point, and I hope I made it clear. Yeah, I think that's all.
Okay, thank you. Okay, I see. Are there any other questions from the audience? Okay, well, let's quickly move on then. So the next meeting will be in another 2 weeks. So we'll meet again on July 23rd, 2026 at the same time. And hopefully we'll have more news from Argentina, from Xenon at that point. Well, thank you everyone for joining. And you're welcome to join our Discord server, the Telegram group, as shown to the left here. As well as once again, it will be a couple of slides forward. Once again, yeah, we welcome you to join us on our subreddit and also on the Telegram's news channel. Okay, well, thank you very much for joining, and we will see you in another 2 weeks.